Hello and welcome. Thank you for joining our Math podcast. Normally we are at the Museum of Math in New York City, but for obvious reasons we are at our homes. In the meantime, we hope you appreciate our Zoom backgrounds as we try to make things a little bit more familiar.
Using extraordinary time-traveling technology, we have managed to call back to 1890, and we are speaking with Sofya Kovalevskaya from Russia.
Welcome, Sofya. I hear you're actually in Sweden these days, is that correct?
Thank you. Yes, I'm residing in Stockholm at the moment.
We know that you have quite a few mathematical accomplishments to your name. What we don't know is how you got there.
What can you tell us about your early life?
Well, I was born in Moscow, Russia in 1850 to Vasily Korvin-Krukovsky and Yelizaveta Schubert. My family had money and I was educated by tutors and governesses. My walls were papered with lecture notes on differential and integral analysis.
So it sounds like you're very supportive of you learning mathematics.
Actually, no. My uncle Peter respected mathematics greatly and spoke of it often as I was growing up. But aside from my conversations with him, I was largely self-taught. My father wasn't supportive of my mathematics education at all. In fact, I wanted to go to university to study mathematics, but my father wouldn't allow me.
Well, surely he couldn't have stopped you.
Yes and no. In Russia, women were not allowed to live apart from their families without permission from their husband or their father.
Well, we know that you were the first woman to receive a modern-day doctorate degree in mathematics, so clearly you found a way to get at university. How did you manage that?
I married Vladimir Kovalevsky, a paleontologist. I didn't love him at the time, and we spent most of our time either apart or arguing, but marrying him allowed me to travel to Heidelberg. Of course, once I got there, I learned that women weren't allowed to enroll at the university. So with the permission of a few professors, I was allowed to sit in on lectures unofficially. Professor Leo Königsberger was particularly influential, and in 1871, I left Heidelberg for Berlin for a chance to study under his teacher, Karl Weierstrass.
I take it that Berlin had better rules about women studying at university?
That would have been nice, but no German universities were allowing women to enroll. And when I first spoke with Weierstrass, he sent me away with a set of problems that he didn't expect me to complete. I showed up the next week with the solutions and he was blown away. After this, despite his best efforts to convince the university of my worth, I still was not permitted to enroll in courses, and he decided to tutor me privately instead.
How did you manage to complete your doctoral dissertation with private tutor sessions?
While studying under Weierstrass, I wrote 3 papers on partial differential equations, abelian integrals, and Saturn's rings. He felt that all 3 were worthy of a doctorate, and in 1874, I was granted my doctorate from Göttingen University.
Out of the 3 papers, which did you enjoy working on the most?
I don't know if it's fair to pick a favorite. I enjoyed all of my studies. However, I will say that my paper on partial differential equations was the most popular within the mathematics community.
Believe it or not, we're actually familiar with your work in that one. Today it's part of what is known as the Cauchy-Kovalevskaya theorem. Would you mind elaborating on it for some of our listeners that maybe don't know what it is?
So the solution of partial differential equations involving a time derivative of order n is uniquely determined if the time derivatives up to the order n-1 of the dependent variables are specified at a single surface, provided the surface is a free surface.
Could you explain that in a way most of our viewers will understand?
Consider a partial differential equation involving m dependent variables and n+1 independent variables, in which there are m different analytic functions of a point subject to boundary conditions. The theorem states that the differential equation has a unique analytic solution regardless of the type of differential equation.
What influence or application did your theorem have on the community?
The original problem was proposed by Augustin Cauchy, but he was working with a special case. I ended up proving the generalized theorem. Truth be told, in the grand scheme of all things differential equations, it plays a very basic role.
Your achievements are quite incredible considering the obstacles you faced and overcame. Did this accolade allow you to obtain an academic position?
Unfortunately, no. Although I was the first woman to obtain a doctorate in mathematics, I was unable to pursue a career as a professor due to my gender. I was offered a job in teaching arithmetic to primary grade level school girls, which I did not accept.
I take it you felt quite frustrated with the lack of support within the academic community. What did you do in the meantime?
I took a 6-year break from my research. For some of this time, I stayed with Vladimir, and it was as if we were a true married couple for once. We had a daughter in 1878, and I took care of her for a year until it was time to return to my studies of mathematics. I left his side again in 1881 for my studies, not knowing that it would be the last time I would see him. He committed suicide in the spring of 1883.
How did your husband's suicide change your life?
I felt a lot of guilt from leaving him again, but I quickly immersed myself in more mathematical work to get through my depression. I did not have the luxury to wallow as a mother with no husband.
And what did you accomplish after you began your studies again?
In 1884, I finally achieved an academic position as privat docent, thanks in large part to Gösta Mittag-Leffler, who held me in high regard to the leaders of Stockholm University. I was appointed a 5-year extraordinary professorship that year, and in 1889, I was the first woman in the 19th century to hold a chair at a European university.
It is incredible the lengths it took you to achieve your dreams, and it shows just how difficult it was to be an educated woman in mathematics. What else did you accomplish with your years at Stockholm?
In 1887, I collaborated with Anna Leffler, an advocate for women's rights and writer, and we wrote a play entitled The Struggle for Happiness, inspired by the death of my beloved sister. Again, grieved, I looked for different outlets to help my grief. In 1888, I participated in a new competition for the Prix Borden and submitted my paper along with 14 other anonymously submitted papers. I was the first woman to win the Prix Borden of the French Academy of Science.
After your 5-year professorship in Stockholm, did you seek different opportunities?
I deeply wished to travel back to Russia, but the government would not allow me to teach. While I couldn't return to teach, Russian mathematicians worked to give me an honorary membership to the Russian Academy of Science. I sought positions throughout Europe, but again felt the sting of rejection. I decided to renew my professorship in Sweden.
It seems as though you had to prove yourself worthy countless times, and still it was not enough to open the doors that you so rightly deserved. What are you working on now?
Actually, I wrote a novel entitled Memories of Childhood in Russian, and the Swedish version, published in 1898, has the name Ravsky Sisters. The Russian version was published this year. I'm currently working on the Russian version of my second novel, A Nihilist Girl, written in Swedish and published this year as well.
Thank you so much for taking the time to answer this unusual call and answering all of our questions. Would you like to know anything about our life in the future?
What year are you calling from?
2020.
How incredible. Are women in a better position in society?
Yes, however, there are still some ways that women are not truly equal to men. In comparison to your experiences, women have many more liberties. We are able to vote, go to school, travel, and live alone. We do not need our father's permission nor a husband. We can run for office for the highest level of leadership in most nations. Some nations are not as advanced as others.
Well, I'm glad to hear that women are treated with more dignity in the future, but I wish that future could be seen in my lifetime. Surely it isn't until the 21st century when these changes take place.
There were many movements in the early 20th century that prompted changes, but it was not something that changed overnight. Change often takes time.
What are the big mathematical discussions happening right now?
Well, actually, the world is facing a huge pandemic right now called COVID-19. So many people, even those that aren't typically interested in math, are talking about exponential functions. It is a scary time in our world at the moment.
How bad is it?
Well, put it this way, Sofya. In less than a year, you're going to die from influenza complicated by pneumonia, and COVID-19 is much worse than that.
Probably wasn't the best idea to tell her that. Sofya, we're going to have to let you go.